Welcome to this session. This is the continuation of file organization part 1, wherein which we had seen the definition of the file organization and then we had seen two different techniques. One is the sequential file organization technique and the indexed sequential file organization technique along with the advantages and the disadvantages. And we will go through another set of file organization techniques in this particular session. Let us start with heap file organization. This heap file organization is the simplest file structure in an unordered file or heap file, wherein which as and when the file comes, it is being heaped. Like there will not be any ordered kind of storage. As and when the file comes, it is being stored. So, the data in the pages of a heap file is not ordered properly. In the earlier two techniques, we had seen there it is following a kind of ascending order or else some sort of sorted order in the sequential as well as in the indexed sequential file organization. Here it will not follow any kind of order. Every record in the file has a unique RID, record ID. RID means record ID, you have to remember, and we will be speaking this particular RID in the next following slides also. And every page in a file is of the same size. So, these are the two things that you have to remember in the heap file organization. One is it does not follow any order, but each and every record is been identified with the proper RID, record ID. Records are inserted at the end of the file as and when they are inserted. Once the data block is filled, the next record is stored in the new block. This new block need not be the very next block. It may be at any space provided by the file manager and is being linked to. So, it may not be the following or consecutive locations, however, it may be some other space where in which the complete address pointer is being given. This method can select any block in the memory to store the new records. So, here whenever the DBMS follows the heap organization method, the complete files are being dispersed on the hard disk, because it is not completely following a kind of sequential storage, it is not following a kind of sorted order, and whenever the record comes, it is throwing that record on any part of the thing. However, it is remembering the record ID. So, it is similar to file in the sequential method, but here data blocks are not selected sequentially, they can be any data blocks in the memory. So, this is kind of randomized distribution. The whole space is being used depending upon the technique that the file manager is following. It is the responsibility of the DBMS to store the records and management. So, even though this particular DBMS file organization technique is very easy, simple, however, it is costly also. Costly in the sense while retrieving, proper data may be retrieved or not, we do not know, and the data blocks are dispersed all over. Disk space management tool should be used thoroughly and quite frequently also. Then supported operations on heap files. As you know, on the sequential file organization we had seen how to retrieve the data using the sequential file organization technique, how to create and then how to insert, how to delete. And once again in the ISAM also we had seen how to insert a record, how to delete a record, how to once again place in a sorted order, those particular things we had seen. And then the overflow, the overflow block and other things we had seen in the ISAM method. Here also some operations on heap files we can perform. One is the create and then destroy and then insert a record with a given RID, delete a record with a given RID, get a record with the given RID and scan all records in the file. These are the 6 operations that we can perform on the heap files. Then there are two alternative ways. One is the linked list of pages and the other is the directory of pages. So, whenever it is following a kind of randomized and simple approach, however, on the physical storage it should be managed. Suppose if a user is giving some DML command in order to update the data, first of all the record should be fetched. It can't waste time on going from one record to other record, but there should be a kind of mechanism wherein which the data block the user intends to update needs to be fetched. So, for those reasons there are two alternative ways, one is the linked list approach and then the other is the directory of pages. So, let us see these how these two alternative ways works in the heap file organization. We will start with the linked list of pages. In the linked list of pages, one possibility is to maintain a heap file as a doubly linked list of pages. So, here we are using the data structure called as the doubly linked list. In the doubly linked list, you have two pointers front and back. At the front end and the rear end, you will have the two address pointers pointing to the following as well as reverse pointing also. So, in between some nodes will be there where in which the record is being stored. One possibility is that a header file needs to be maintained. DBMS can remember where the first page is located by maintaining a table containing pairs of heap file name and page 1 address. So, somewhere somehow the start point should be mentioned because the following address will be stored in the doubly linked list. Likewise, the reverse also will be stored. So, here we have to mention only the starting address so that if first record is being fetched, obviously the last field is the address of the next block and once again the last field will be the last node will be the address of the further blocks. So, likewise we can move on. So, it is essential in this particular heap file organization technique to know the heap file name and the page 1 address. So, these particular two fields, a pair, is the prominent thing in maintaining the linked list data structure of the heap file organization. Let us see this. An important task is to maintain information about empty slots created by deleting a record from the heap file. This is the major task. When we are linking these particular records using the doubly linked list, if one of the record is been deleted, obviously we have to relocate the pointers of the doubly linked list. So, in between, suppose if you are deleting the record, we have to set the pointers perfectly to the next block after the deletion is over. However, whenever we are taking these particular files, whenever we are deleting the space over there after the removal of the record, we have to throw it into the free space area. That particular node needs to be updated in the free space area. So, once again we have to see which are free spaces and which are full pages. So, these particular things need to be taken care. Just see the task, there are two distinct parts: how to keep track of free space within a page, how to keep track of pages, those are free. So, the second part, how to keep track of pages, those are free. We can address this particular issue using this doubly linked list for free space as well as for the full pages. If a new page is required, it is obtained by marking a request to the disk space manager and then add it to the list of pages in the file. Suppose if you are creating for the first time a database and there are several records. So, we will see the disk space manager, we will send a request to the disk space manager. That disk space manager fetches you the space from the list of pages in the list of free spaces maintained. So, those particular free space area is being fetched and is being allocated, and then a proper header file is being set. If a page is deleted, once again from the heap file, what it does is it removes and then it throws into the free space area and then proper pointers needs to be set. So, these particular two functions are primary functions in the doubly linked list for the heap file organization. Then this is the illustration shown over here. This is illustrating you the doubly linked list method. Here just see a header file is there, wherein which the file name as well as the first pointer, this is the first page wherein which it shows the thing, and then these are the things later on files wherein which all the records are being followed. And then the disadvantage is virtually all pages in a file will be on the free list if records are of variable length. To insert a typical record, we must retrieve and examine several pages on the free list before we find one with the enough free space. Here you can see, suppose if there are fixed lengths in the records in the doubly linked list, then it is not a problem. Suppose if you are having a variable length, within the variable length, suppose if some of the space is being occupied and the others are falling empty, that is one of the disadvantage. We are maintaining the free space for the complete free space files records, but we are not taking care of the space which is left over for the variable length records. So, that needs to be taken care. This is the disadvantage with the this kind of doubly linked list. However, this can be overcome in the directory based heap file organization. Let us see what is the technique followed. In the directory of pages, an alternative technique to maintain directory of pages is there. In this, it is overcoming the disadvantage with the doubly linked list. DBMS must remember where the first directory page of each heap file is located, and then the directory is itself a collection of pages. Each directory entry identifies a page in the heap file. Here what it is doing is, in the doubly linked list only the priority is to identify the header page, and following on the other records are being followed, like record 1, record 2, record 3, as well as the pointers are being set. Likewise, for another doubly linked list is maintained for the free spaces. So, in the directory of pages, it maintains a kind of directory for each and every data block. So, a pointer will be there from 1 to n pages in the directory. Let us see the illustration so that we can understand it very easily. So, this is the illustration of heap file organization with a directory. Here the header page, each and every header page consists of the directory, and the first location is called as the header page, which points to the data block of page 1, and the second location points to data block of, we can call it as the data page 2, likewise third block, likewise n block. So, each and every entry of the data page will be there in the directory. The starting location is called as the header page, following on there are n data page entries. So, here the technique that it is following is, one thing is whether it is free or not. So, a kind of bit is maintained whether the page is free or not. Depending upon that, easily one can see whether it is a free page or else whether it is occupied. The other thing is, it can maintain a kind of index wherein which it can show the length of the space, that also can be maintained. So, whenever the request comes, first of all it fetches the nearest length, like fitting length, and then that particular free space can be procured and been allocated. So, here the space wastage will be very minimum when compared to the doubly linked list if we maintain the variable length of the records. Here it goes to the nearest space that it wants, and then it procures that particular space. Here the space wastage will be very minimal. So, both the things can be taken care. One is whether it is free or not by a kind of true or false mechanism or else 0-1 kind of mechanism, a bit entry mechanism, and the other thing is how much space is there for each and every data page, and all the data pages are not of similar sizes, they are of variable sizes. So, the nearest length that it requires can be seen and can be procured. So, next comes the multi-key file organization technique. So, till now what we were saying is only we are accessing the record with a key field, like we had seen in the sequential method how the record is being fetched using a key and it was maintaining some index file also. In the indexed sequential file it was maintaining the index also. So, there it is being clubbed with a kind of address also, and only we are working with one key in the earlier methods. Here indexing can be done with multiple key also. So, it allows records to be accessed by more than one key field, not only the primary key, secondary keys also can be indexed. The ability to search on many keys is enabled by building multiple index files on top of the data file. So, data files are stored over there, and then earlier in the ISAM we were using the primary field only in order to create the index file. However, in multi-key file organization it works with the other key fields also, the secondary keys. The physical database consists of one or more data files and many index files, and each data file contains either one or several record types. So, how these things are possible, let us see. There are two approaches, one is the multi-list file organization and inverted file organization. Both of them varies at one part, which we are going to see in the next slide. Like an index for each secondary key is maintained. For each secondary key, for each and every secondary key, the index has been properly maintained in the multi-list key organization technique. An index entry for each distinct value of the secondary key. Whenever there is a distinct value for the secondary key, suppose if the keys are identically the same, the values of the keys are identically same, then it will be taking only one entry and pointers will be there. However, whenever it finds a distinct value, another value other than the stored value, then it once again have a index entry in the index file. The index may be tabular or else tree structured. The entries in an index may or may not be sorted. The pointers to data records may be direct or may be indirect. So, these particular things are common to both the approaches. So, let us see where lies the difference. An entry in an inverted index, this is the first thing that we were seeing, this is the first approach, has a pointer to each data record with that value. So, each and every record will have a pointer, but in case of the multi-list index has a pointer to the first data record with that value. So, there the entries are more. In the inverted index approach, each and every value will have a pointer. However, in the multi-list index, it will have one pointer to the first record and the others follows. So, that there lies the difference between the inverted index and the multi-list index. Inverted index may have variable length entries, whereas a multi-list index has fixed length entries. Why? Because there each and every for each and every data record with the value, it is having a pointer and variable lengths can be maintained inside. But in the multi-list, it will be having fixed length entries wherein which it is evenly distributed. Only the header page, like the first pointer will have to the first data record, and later on the other things are being linked using the address part. So, this is the basic difference between both the approaches. So, another technique is there called as the hash or direct file organization. Till now we had seen the sequential file organization technique, the indexed sequential file organization technique, and then the multi-list key organization technique, heap file organization technique. Here we are going to see a new technique called as the hash file organization technique. In the hash function, a mathematical function is used over here. Hash function is used to calculate the address of the block to store the records. So, this particular hash function is nothing but a kind of simple or a complex mathematical function which works along with a key. So, the key value in the table will be used and a mathematical function will work on that particular key value and calculates the address in the storage part. So, this hash function is applied on some columns attributes, either key or non-key columns, to get the block address. Hence, each record is stored randomly irrespective of the order they come. So, once the record is arriving, it will take the key part, whichever is identified, whichever is given in the mathematical function, that part it will takes, and upon that particular part a mathematical function works, and then both the combination calculates the address of the block where this record should store. So, the record stores randomly, however, but once again whenever we want to retrieve that particular record, the function, we will see the function, it calculates, it fetches the address directly, it goes to that particular address, it fetches the data for you. So, this is the easiest technique, however, it is a costly technique and complex technique. So, this method is also known as direct or random file organization. Why? Because it is directly fetching the records from the storage area. If the hash function is generated on a key column, then that column is called as hash key, and if the function is generated on non-key column, then the column is called as hash column. So, key column, whenever it is if a field is been identified as a primary key and a mathematical function is working on that particular key, then it is called as the hash key. And if it is identifying a non-key, we had set a non-key, either it is not a candidate key, primary key, secondary key or foreign key, and a non-key is being identified, then some mathematical function is working on that particular column, it is called as the hash column. So, when a record has to be retrieved based on the hash key column, the address is generated and directly from the address whole record is been retrieved. Similarly, when a record has to be inserted, the address is generated by the hash key and record is directly inserted. Same is the case with the update and delete functions also. So, what are the advantages? Records need not be sorted after any of the transaction, hence the effort of sorting is reduced in this method. So, no need of any sorting mechanism, the whole thing is being on the calculation of the mathematical function working on some hash key. So, there is no need of keeping track of any kind of index files and other things. However, the hash function whatever is working plays the prominent role. Since block address is known by hash function, accessing any record is very faster. Similarly, updating or deleting a record very much quick. This is one of the advantage. And then this method can handle multiple transactions as each record is independent of the other. So, suppose if you are transferring multiple records, so each multiple record is being working with some other with the key field along with the mathematical functions. So, multiple records can be easily and simultaneously can be handled. It is suitable for online transaction systems like online banking, ticketing, booking system, etc. So, coming to the disadvantages part, since all the records are randomly stored, they are scattered in the memory. So, once again disk space management tool should be used quite frequently in order to release the wastage of disk space. Hence, memory is not efficiently used, we have to use some sort of tools in order to properly once again rearrange them. If we are searching for range of data, then this method is not suitable because each record will be stored at random address, hence the range cannot be specified. So, suppose from this record to n record, if we are specifying the range, it is not a good mechanism, it will because it is been, they are not sequentially stored and randomly stored on the disk storage. So, each fetching those particular range records is not a wise thing in this particular technique. Searching for records with exact name or value will be efficient. However, if you are putting a wild character along with the main character, then also it is not an efficient technique. This method is efficient only when the search is done on hash column, otherwise we will not able to find the correct address of the data. So, before concluding this particular session, once again we will have a recap. In the first file organization 1, we had concentrated on the simplest techniques called as the sequential file organization technique and the indexed sequential file organization technique. In this particular session, we had started with heap file organization, which is the simplest technique, and then we had seen the multi-list kind of thing, and later on we had focused our discussion on the hash technique. So, hope you understand all these 5 techniques, which are very much important whenever we are dealing with the database management system. It is, as I told you earlier in one of the sessions where I was talking about the database administrator. So, the correct file organization technique needs to be identified for the operations that are going to happen on the database management system. So, understanding all these techniques, one can obviously judge which technique needs to be followed on the DBMS and what kind of access method one needs to identify in order to fetch the data easily and efficiently within no time. So, with this I hope you understand the session. Thanks for your attention.